attempting to stream live all at once. It is saying unstable on YouTube. Let's see how that goes. All right. If things get out of hand, I'm trying to look at a bunch of stream chats here, various chats, and yeah, okay. I don't mean anything like that. It's basic sort of basic procedural AI. It's like, okay, it's not meant to be super fancy. It's meant to be sort of convincing from the game perspective point of view. So let's see. Here I am. All right, we'll start off with that, and we'll see where this goes. All right. As I bounce it, too legit. Okay, so present. All right, so let's talk about smart enemies. The first basic thing that an AI needs to do, of course, is it has to be able to sense something, right? That's the idea. You can't be intelligent without being able to sense something. Okay, you got some people joining. Remember to mute your mic until you need to. I kind of heard some folks there. Okay, we'll leave it. We'll leave it live. We're doing it live. Okay. So smart enemies, I see you. So we're going to really talk about the sense that this character is going to have, or that our non-player characters are going to have. We're just going to use vision as our sense. And it's not really vision. Sometimes it's a little confusing. If I say vision, you're going to see, can it look, can it, whatever. Conceptually, it's vision. It's okay. Is it facing in the right direction? Is it looking through an object? Is it blocked by something? Basically, you start simple things by saying, okay, can I draw a line in between where the enemy is and where the player is? And is the enemy facing in that direction? Is the enemy close enough to the player to see? So you have some sort of things of like, you have this sort of orientation of the enemy. You have the distance it can see, and you have its sort of attentiveness. You can do all, you can customize it however you like, right? So it's the basic ICU. Now, before we dive in, I did want to mention this because some people have been asking, there have been some things, and let me see, I got to move my little image up here out of the way. Maybe if I go up there, I will be out of the way here. Any, all, or the current live one. I am currently live on everything, I think. Okay, someone's asking. All right, so in certain cases, so we have the player that we've been working with, the basic character. We've been doing mostly WASD style motion. There's a couple of different tutorials, a couple of different lessons in the playlist right now about moving straight up and down, left and right, using WASD style, and using basically the velocity of the rigid body that's attached to the player to establish how the rigid body moves, how the underlying rigid body moves. And also I started in those, if you look at the ones that have the bird with the flapping wings, that one gets interesting because it's using sort of a combination. You can switch between these sort of tank style, which is sort of move yourself in a certain direction, then or rotate yourself in a certain direction, then move in that direction. Also very boaty or vehicular sort of motion, as opposed to what do they call it? Holonomous. There's a word for being able to move immediately in any direction. It's I came up with how many of you are familiar with BB-8 out there? Everyone chime in, right? BB-8 is a very interesting robot because it can move in any direction at any time without regard for what orientation it's in. So I think that's a holonomous. I'm just failing on my terminology. Robot or movement there, as opposed to other things where you have to do like some sort of turning and then move in that direction, or gradually turn while you move, and so on. It's very interesting. There's lots of different modes of motion. But anyway, for now, we'll consider these kind of two main ones. One where it is sort of WASD style, move in any direction at any time and immediately change the speed that you're moving in that direction. You can do that just by moving the player, changing its transform, or what we like to do better than manipulating its transform is we want to manipulate or cause some sort of force or movement in the rigid body, the physics rigid body that's attached to the player object, so that the player object will interact with the physics system, right? That's why we're using this rigid body interaction as opposed to just moving things according to their transform. So remember that. I'm going to be looking for that in this project and the next project. So this is, on this slide, it's sort of the how to do it if you want to rotate and then move sort of thing, right? So what we're doing is we're getting the two axes, the horizontal and the vertical, but we're not really using them as horizontal and vertical. We are really just using one to establish, okay, what speed should be going in, so how much forward, right? So you can still go forward, and the other one being how to rotate, right? So the y-axis, which would be the the W and S, or the up and down arrows, that is going to establish your velocity, right? It's going to push you towards towards your up direction, toward that particular axis. And you're going to use the other axis, the X, to rotate the rigid body, which is in turn going to affect the direction of that transform dot up, right? So by changing the angular velocity, you're continuously changing the transform dot up for that object, and then you can just move in that direction. It's pretty cool. All right, so this one slide shows you how to do, some tank style motion with a little bit of tuning here. Maybe you want to change, how quickly does it turn? How to be responsive? Is it really just this factor of 5 for the velocity, and this factor of -180 for the, overall how much can it spin? So you can do that. So that's not really AI, but hey, we'll leave it at that. All right. So we haven't been stressing a lot of math in the course. And this is one of the cases where the dot product, I think I referred to this in some earlier slides. If I haven't, I'm just getting some out of whack over the summer, just like everybody else, because time is a relative thing now. And dot product is one of the most important math concepts, that we're going to have in game math, right? Because we like to use this thing where we can quickly calculate a relationship between two vectors, right? So if we take two vectors and we calculate the dot product of them, we can figure out generally how similar they are in terms of their orientation, right? So we take the dot product, we get back 0 when they are perpendicular, or they're just orthogonal. They do not face in the same direction at all, or in opposite directions. One is, just 90 degrees from the other, right? If it goes negative, what's going to happen is basically one might be pointing in this direction, the other one is going to be beyond 90 degrees. So they're sort of pointing to some degree opposite one another, right? But then the moment they become positive, they're going to start to go in the same direction, right? Now, it's nice to work with normalized versions of these, because when they become 1, they're pointing in exactly the same direction, as opposed to, the span across. You can say, okay, within how close of one another do you have to be to see one another? And we're going to use that to sort of establish a field of view, right? Because it might be that we want the enemy to be able to see the player over here within some range. And without doing any trigonometry, we can say, okay, if the dot product is greater than 0.8 or 0.7, whatever you want that field of view to be, we can say, okay, we're facing enough towards that it's good enough to see, right? Now, we're not concerned about this, the player, what direction is the player facing, really. We're really just concerned with the direction that the non-player needs to point in versus the actual vector that would point, right? So that's what we're really comparing. We're not comparing the orientation of the player up here versus the orientation of the non-player. That's one important part. One is the position of the player, and the other one is the orientation, right? So it's a little bit funny that way, right? So we create this target vector, which is the vector in between the two, the sure thing, the thing that points directly. And then we compare that, the normalized version of that, to the place that we're pointing in, right? That transform dot up, right? Very convenient way to do that, right? Now, it's a little bit weird when we're talking about, now we're talking about rotations and angles and pointing in certain directions. And in the case of our movement, we haven't rotated anything yet. So there is no real angle or orientation change normally between, say, the player and the NPC. They're not, in our RPG, we're using lots of words, letters here. In an RPG, the characters are always moving up and down, left and right, and so the NPCs. So they really don't rotate with regards to one another. So we have to do something else to kind of figure out, well, what is that field of view, right? Field of view is going to be an interesting one in that case. And you'll see how I've approached it in the game that I've been working on, this sort of little RPG, where I have a indicator as to where the characters or the player or where they're looking, right? So I superimpose this notion of some directionality on top of the motion, which is one way of doing it. So in this case, we have those numbers, we have the normalized vector in between, and then something about the orientation to see, are you facing in that direction? And then you say, okay, is that greater than that magic number that you use as your kind of field of view, right? So that is the one magic bullet of one magic bullet with regards to seeing, quote unquote, seeing the player, the enemy seeing the player. Now, the tricky part with that, or the weird part about that, is that it's really cool. However, it doesn't take anything into account with regards to what might be between the player and the non-player character, right? Is there a wall in between? Is there another non-player character in between? Is there whatever, is there an object? Is there a mountain? Is there a door? Is there a wall? So it's useful, but not entirely useful, right? Because it's not on its own, it has that problem, right? So we have this other thing, which is more an engine function, thankfully built in, called ray casting and line casting, which is part of the physics system, which uses the collisions, the colliders, the other data structures, and so on, to figure out, would certain objects or certain lines or rays, would they collide with colliders if we projected them into the scene, we cast them into the scene? This term casting is often used to say, okay, we project something into the scene, we cast it in to see where does it lie, where does it fall, what does it hit, right? So you'll hear that casting term used a lot. Now, ray casting is casting a ray, which is normally going to have, a direction. It's sort of a vector. It's a direction and a length. And the sibling line casting is usually, we have a line with a beginning and an end. So we either are casting according to a vector using ray casting, or we have line casting where we have between 2 points. Now, the interesting thing about ray casting, we sort of break it. A ray is generally a vector and then a length, and we kind of be a little bit more excited there. But anyway, it's a little bit odd. So this is really useful for finding what colliders are hit by some imaginary line or ray from a point in a certain direction. It's useful for seeing what objects occlude one another, because if you have colliders, you can see, okay, it is hiding behind this wall because the wall has a collider, right? So we're going to be using the physics 2D version of this. Is a physics 2D and just a normal physics version. So for now, since we're in a 2D game, we're going to be using physics 2D. And I'm not going to go into the real nitty-gritty of these functions, because there's lots of different versions. There's lots of different overrides in terms of what parameters you need to provide. And one of the things you've got to get used to in game programming is that APIs are changing and functions are changing. So you got to read the fancy manual. And so this is one of those cases where, especially with regards to ray casting, line casting, and so on, that you really want to refer to the Unity manual, or eventually could be the Godot manual or the Unreal manual, and so on, to kind of see how they're ray casting, how they're line casting, how these functions work. Okay. But for now, I'll mention a couple of things about it. So to cast a ray, We cast it from a position, right? So you have to say, okay, put the transform, or excuse me, put the vector starting at that position, and here's the vector. Here is the length of the ray. So we can have an infinite ray, which is sort of like an infinite line emanating from a certain point, right? And then this last one you'll see in a lot of the code and examples that I do, this is actually a layer mask. And I apologize, this slide isn't offering a lot of detail on what it is, but it's basically a way to say, okay, what layers, now by layers I mean the physics, remember the collision matrix? Hopefully people remember the collision matrix. Normally, let's see, some people nod their heads. The collision matrix in Unity is where we get these layer IDs or layer numbers from. So we can say, okay, what layer are we interested in? So if I shift a 1, this is a bit field, right? This is kind of interesting because I may be interested in multiple layers. So that's why it uses a bit field for this layer, right? Another thing to look, check out your Unity manual for when you talk about layer masks now. I think in some of my tutorials, I go a little bit deeper in, which is good. So this is creating an ad hoc and on-the-fly layer mask that says, okay, whatever is on layer 8 is the layer that I'm interested in, right? I shift a bit 1 by 8, so it puts that in the 8th position, meaning the 8th layer. Now, this is why in Unity, you'll see you have a finite number of layers because you need to be able to pack them into these layer masks. And generally, that's what's going on. All right, so this will result in a hit. You'll get a raycast hit 2D, this hit. And from there, a hit is similar to like a collision that's returned by a collider or a collision object on collision entry 2D and so on, right? And it has lots of stuff about it that you can check into. And here, I'm using this little shortcut to say, okay, if something returned that wasn't null, I could have said if hit does not equal null, then check all this stuff out. But there's a little shortcut to say, okay, this little question mark enforces or prevents an error here of a null check, right? But basically it's saying, okay, did I hit something, or what is it that I hit that is it named player? And if true, then go ahead and do what's in here, right? So this means that yes, the line in between the two hit the player. So if it hit something else sooner, that's what's going to get returned. I didn't see the player, right? Because it's going to have the player or the NPC here, the player here. If there's no objects in between, that ray is going to go right between the two. If there's an object in between, the ray is going to hit that object. Okay. Now it has to have a collider of some sort on it in order to get hit. So objects that are just graphics, those will get run over. They get passed through. So this is what's going on here in this piece here. So you have these two things, and generally, what I find to be a useful approach to this is you want to use some combination of the two, right? Because a raycast does not take into account sort of how close something is. It has to be exactly in line, right? And the dot product really doesn't know is anything in between. So I use a combination of the two. Right. And which one comes first is a little bit of a matter of preference here. But typically in a fixed update, what I'm doing is I'm calculating the vector that would be in between the two objects I'm interested in, right? The other being the player and the transform here being the non-player. So I calculate a target vector that is the one in between the two. Then see, okay, is that within the field of view of the orientation of this non-player, right? That's this part where I'm using the dot product. And then last but not least, then I go ahead and check that raycast to see, okay, does it point? Is there a clean shot? Can I see through the window, see through the doorway, see through whatever to actually get there? All right, screen here, I'm gonna give it a shot. All right, so, and for a moment, I'll turn that off. You don't need to see me, right? How's everybody doing? Is our stream's keeping up? Everything okay? Give me a thumbs up, someone. Only have 1, 2, 3 people paying attention over in this Discord voice chat for that Discord channel at the moment, but Let's assume it is okay. All right, so here we are in Unity. Pull up the game. All right, this is my little NPC game here. If you've been following my sort of live devlog stream, whatever you want to call it, dialogue system and a couple other little things and squirrels that follow me around. Just types of enemies. There are these, well, enemies, squirrels aren't enemies. If you are seen by a squirrel, the squirrels will happily follow you around. Now, on the other hand, if a non-player notices you, they'll start to chase you and it will shoot you, as opposed to the squirrel just happily sort of following along. You can collect squirrels. It's kind of cool. All right. And you notice if I bump into squirrels or I bump into the street, like, you reach the center of town. All kinds of neat stuff in here going on. All right. So let me do a little bit of debugging here. And this is some debugging that let's do this. So I'm going to go to the game and on play now, so we can kind of see what's on. Now, let's watch over the scene window. Now, you've all done debugging where you, but not in the debugger, but here in the sure that there's nothing that's going to shoot me. There we go. All right. Now you'll notice a whole lot of lines in here. Hopefully you see a whole lot of lines. And what these lines are doing, they are a quick visualization of sort of some of the relationships between the player and the various non-player entities, right? So you'll see them sort of every so often. And I'm going to move my player around a little bit. Let's see. We'll get into the way of this squirrel. Well, the squirrel, I guess, is sort of behind this squirrel. Okay. Let's see now. You can see the squirrel's line is now red. Interesting, because things won't be able to see me around one another. Kind of crazy. Okay. So what do those lines mean? Where are they coming from? Let me show you. So let's go over to Visual Studio. Now we'll kind of step through our code here a bit. So I have a couple of different enemy AIs. This is the basic one that things are following right now. And all of this kind of going on inside of fixed updates. There's a couple of extra things, but for the most. So this, well, sorry. Okay, we start off by doing what I showed in the lecture notes. All right, we start off, we say, all right, we have the hero's position and we have the non-player's position. I'm working just in ease of use. So I calculate a vector, a hero vector, H vector, which is pointing from the non-player character to the hero, right? Vector that points between the two. Now, let's see some things. We have some debugging going on. This is the part I was saying about debug.drawLine. Okay, so this is really helpful for visualizing what's going on, you know, in the players or in the logic here. Draw a line in between the position of this is the non-player and the hero, and it's going to use the black color. Okay, so we just have a basic line, a black line showing the basic relationship between the NPC and the hero. Hit play. Suddenly, everybody has some line pointing at the hero. All right, there's probably 24 lines there. Fine. That's the first one. Now, the next thing we're going to see is we're going to draw an array. Array is going to have a certain, it's going to have a distance, it's going to have a direction, and it's going to have a length. All right. So drawing array at the position, what I'm going to do is I'm going to draw it. It is using this rotator, which is that little arrow that's pointing around. So what I'm doing is I'm continuously rotating that arrow around them so that we can see where they're looking, right? So I'm using this their up direction of their rotator. And so we visualize that as the direction, that's the vector, and it's going to be a length 5, right? So that is the up direction of that rotator object. Let's see what that looks like a little bit. We'll go now down to prefabs, just so that you understand. And we'll go to, there we go. There's an NPC here. It has, actually it's the basic one. It has an animator, so it kind of walks. It has a damage script, and it has its renderer. And then it has a child object called a rotator. And the rotator is really where that arrow is, right? Right, the arrow is on the rotator. Just kind of an extra. Why is it like this? Why is the rotator and then the arrow? Well, that's a convenient way for me to offset. You'll notice that the arrow is offset by 1.5-ish, right? So when I rotate this, which is centered on the player, right, it will rotate around the player. Or the non-player, right? So it's a little bit of a fancy hierarchy here. I'm going to go ahead and set that back to 90 or -90. So I have this child, which is going to rotate relative to the actual non-player, right? So that allows me to continuously change this orientation, right? The rotator, you'll see right away, the rotator up is pointing in that direction. And as we rotate it, that up, very convenient. That's what I created. Feel free to get as fancy as you want with that one, or not. You will see in here that sweeping blue ray, which is the gaze, the direction that NPC is looking in, right? You can't notice that comes around and sees you. Right? So there we are. So we have this rotating gaze. If it's not engaged, and engaged is a Boolean that says, okay, the moment it can see you, you're close enough, all of the planets align, the moment it gets engaged, then we're not going to bother looking around anymore. But for now, if we haven't seen you yet, we haven't seen the player yet, this routine here, rotating that object, rotating the rotator, and it moves it by a fixed amount here. Wow, it's in fixed update and using time delta time. Interesting. That's a bug. I should fix it. Excuse me. Just to have a fixed amount there. And then we do a couple of things. We ask, okay, first off, is the player, that magnitude of that vector, the magnitude that, the distance between the two, is it less than 5? So we have to be within 5 units, 5 meters of the player in order to notice it. Then we go ahead and we color that line green, meaning, yep, we're within range. We haven't seen it yet, but at least we're within range, right? And then we do a ray cast. You could do it either a line cast or a ray cast. Is one of them. I said, okay, here's the line in between the two, and here I suppose I could have just said, okay, well, let's adjust that distance, and then we could more or less do away with this other one. If the magnitude, we could say, okay, only cast a ray that's long enough to reach it. So it could go away. Get rid of that one if we wanted. But for now, let's continue. All right, so here is the important part to say, okay, can we cast something through? Does it collide with any objects? And we can say, okay, if it hits something, let's check what is. If it was the hero, the player, well, then let's make sure that it was facing close enough to that dot result in order to see it. And if so, then we set that so we can see it. And we also set the player or the orientation, the rotator's orientation directly at the player, right? We just lock it in and we say engaged is true. Engaged, and as long as we're close enough, we are going to, or within a certain distance, we're going to use this move position of the rigid body 2D. Now we could have used transform move position. So we're going to change the position of the rigid body by moving it using interpolation from its current position to the hero's position. And pay no attention to this runaway bit. This is I'm going to have a way to like kind of Pac-Man ghosts where you eat the power pill and it runs away, so you could flip the direction according to some amount of time. So there's a bit of a Xeno approach here. Where we're just moving some amount towards the player. This move position. Actual manipulation of position as opposed to manipulating the rigid body. That's another approach. There's lots of different approaches, but this is the one I chose. So that would say, okay, move towards the player. Oh, I know why this is here. This is not to see. It doesn't try to run the player over. It just says, okay, get us close enough. Get us within 3 and then stop moving. Just don't have to worry about moving any closer than that. We don't want to run it over. So our enemies are smart. They don't coins in the direction of the player, right? So we use the rotator's position. We instantiate, let's see, what are we doing here? Yes, we're in that coin on the non-player character's layer, so it doesn't kill other non-player characters. We are then giving it a velocity. We throw it with some velocity, and then we say, okay, the last time we threw something is now. So we 5 seconds, or can shoot every 5 seconds, and this is how you flip a coin at the player. All right. We also have a little bit of a thing in the AI here, in our enemy controller or enemy AI, where it also says around, right? If it's not actually looking at the player, if it's not engaged with the player, give it some random motion. This isn't a pathfinding algorithm. This isn't anything too fancy. This is really just a random meandering thing. If it bumps into a wall, it'll bounce off the wall, or eventually it'll move away from the wall. So it's really simple, right? So it calculates a little force in the direction of wherever it happens to be looking at the time and pushes itself in that direction. Neural nets or pathfinding or anything like that's really just to be sort of just a compelling, simple algorithm. And it works pretty well, right? So we can sneak around. They're moving with sort of random motion, and every so often one will manage to find you. Let's see, we just got the multi up in here. And it's really fun to gather squirrels. I've decided that's my new favorite thing now, gathering squirrels. All right. So let's jump back to the presentation materials, if I can. Let's see. There we go. Present again. All right. So you'll notice we use this move towards, or one of the ways you can move towards something if you want to modify the position is you can move towards something by some step, which you decide what is the step, how large you want the step to be, how long it's going to take. It's a case of check out the manual, and you'll see some details on ways you can use the step value to accomplish whatever speed you want. I'm using basically a speed factor and the delta time to say, okay, move by that much, so that if this was being done inside the update routine as opposed to the fixed update, and it's going to move you from one position to another position. Right, so it's moving towards something. There's also a rotate towards. So if, say, you had a spaceship or something where you wanted to actually rotate towards to calculate a new direction. And let's see. Those are some of the basic techniques. This is a tip I wanted to give you about sprites and ways to use sprites and manipulate them to kind of set things up to own object, its own game object there. You can put graphics and sprites on their own objects so that you can change their orientation, rotate them, make sure that the up vector points in the direction that you want it by just rotating the child object locally as opposed to rotating the parent object, right? So this is what's going on here. So you can make sprites and other renderers children of actual objects if they need to persist, for example, the player. And it also helps with reorienting graphics without upsetting the orientation of the underlying object. So sometimes, I guess this first one is really like, imagine back when we had the baskets, and each of the baskets, we have the player object that persists throughout the whole game, and then the sprites and their other parts were children of the player, so that we could get rid of them and rebuild them up if we wanted to. So that's what that bit there is. But really, this reorientation of the graphics is the one that I'm demonstrating in the in that other piece here. All right. So another thing to mention: spawns, bad spawns. So something about AI, and a useful thing is to make sure that your AI, now your enemies spawn. This is add a enemy to the screen, or you re-add the player back to the screen, and you don't want the player to materialize directly on top of an enemy or an object or something like that, right? So sometimes you have with new objects and the player being reintroduced into the scene, being introduced randomly to the scene, where should they go, right? A couple of techniques. Some of these are more hacky than others. You can always place new enemies at random offsets from the player, and then use a random value beyond that. So there'll be sort of a clear circle from where the player is. You can also do other things like, cleverly turn off the die option in here using collider behaviors and point forces to repel them. So if you have physics involved, they'll push them apart, and then once they're pushed apart, then you can turn them back on again. But that's a little dangerous here. What you really normally want to be using is this combination of casting. All right. Let me talk a little. Well, let's see. Let's jump back over to the other screen and talk about that spawning. It's all within a certain distance here, right? Distance, randomly, but there they are within a certain box. So how do I accomplish that? Well, there's a couple of special things that I've placed in here, and you can come here, which is an invisible object. All it is a transform. And there's also an upper left. Okay. And I'll move them around just to demonstrate. And now let's hit play. You'll see that everybody populated a lot further away. Here. So how did that happen? Well, those are just little sort of mile markers that manager uses when it is building the end. Go to the game manager. I have a little game manager here, and the game manager is in charge of spawning the NPCs, and it also gives us that little. Let's see, when the game starts, you'll see "Welcome to my adventure," and in a moment, it'll say "Befriend the squirrels." And if I click on it, avoid the villagers. Good luck. I can click on that; it'll go away. All right. So we have this script called Make NPCs. It really should be Launch the Game because it has that extra story part. But anyway, it started off being called Make NPCs. And it has a scriptable object, which is a list of potential inhabitants. It has our story intro conversation. It is the number of NPCs to spawn. Let's make this really big. Oh, go for it. What am I afraid of? Squirrels. Oh, there's a couple of enemies in there. Look at the draw. A lot of squirrels. All right. So 64 NPCs. We have our upper left and lower right corners. So what we did, he said, all right, we shared a transform there. Let's look at the script. So this is the Make NPCs script. The cart is that in the start routine, we are populating NPCs. I have a few things in here to set gravity according to, like, okay, if I'm in an RPG game, I set gravity to 0. Anyway, so we have our story intro dialogue about, but here it is. Populate the non-player characters. This is the important thing. This is what I want to demonstrate. I want to talk to you about. And again, this is not the only way to do that. This is one. This is using an overlapping box. There's overlapping circles. There's other ways to get players in a scene according to a box. All right. So what I do first NPC in this game. Okay, you could determine what size box you wanted. You could hard code it in if you wanted to, but I'm just using the size of the box collider that is on the first NPC in my inhabitant list here. Okay, that's what's going on here. Past that box into the scene. All right. Now, I'm going to do this some number of times. Right. I'm going to generate some number of NPCs. Number of NPCs. Safety valve to avoid an infinite loop. So, like, potentially what would happen if I accidentally, not saying I actually did this, but suppose I accidentally created a everywhere so that the player, so that this routine could not place any characters, this would become an infinite loop. Because keep trying to find a location for a non-player character. Keep trying to find it over and over and over again, which is no good. So what I do is I use this safety and infinite loop because there's some logic inside that's going to determine whether or not I can pop out of this loop. It's a good idea to use this bailout sort of technique. All right, so bailout is set to 0 for starters. And you'll notice in the innermost portion of this loop, I have this if bailout is greater than 1,000, return. All right, means something's going on. A fun thing to learn from. All right, so that's our safety valve here in case you're wondering. Now, for int I equals 0 to number of NPCs, we're going to create a random spawn point for our NPC. Right? So we do that by saying, all right, lower right X to lower right Y to upper left Y. So within that range, if I put a box of this size, the size of a box collider, into the scene at that position, do I collide with anything? If I another position, we check it. So we check this up to 1,000 times, trying to find a position to put this non-player character in that it does not collide with. I actually have we haven't created the NPC yet. NPC I'm generating. I'm using that list that I had, that this scriptable object, right? This NPC. Where is it now? NPC list, which is a scriptable from, in this case, 0 to however many potential types of NPCs there are. And it just puts it at that new position with no rotation. So it just creates a new NPC. Boom. It doesn't really even need this temp here. It generates all my NPCs. Now, the cool part is my NPCs, change the number of NPCs or change the proportion or add new NPCs and things like that. I don't have to revisit this code, right? If you look over here in my, where's my NPC list? Scripts, NPC list. This is just an array of NPC types, which are game objects, which are prefabs, right? So this is a list of prefabs that can get instantiated, which is interesting because they don't even have to be NPCs. They just have to be prefabs. Wow. How crazy is that, right? For example, all right, right now, if I look at my make NPC script, okay, here's inhabitants. We'll find inhabitants here. Here's inhabitants. Now, what would happen if I said, okay, I want to have 4 things, and I'm going to go to prefabs again, and some of my prefabs are going to be bushes. I have procedurally generated a world full of bushes. That do not overlap with one another. Crazy, right? All right, everybody. I guess I've sort of like, I crossed that line. I went into like, sometimes I get more dramatic when I think moment, or I'm going to pause for questions. I've just been rambling here. There's really only one, two, three of you watching live on Discord at the moment. Questions? Feeling inspired? How is that? What do you think? How are things? Is your mind blown? Okay. So let's go back to the game for just a moment. And then I don't even know what time it is. It's 2:30. A fun hour of stuff. All right. And this game is definitely above and beyond what I expect for the homework. More scaled back than this. So don't feel too intimidated by this. Right? Start basic. All of the scripts in here, none of them are really all they'll see. As we're going through here, if you look at most of my scripts, even my scripts that are doing my dialogue system, right? But someone was asking this morning about different things and trying to implement a kind of really cool combat system and all that kind of stuff, and that's cool. But what I'd really like to see in the intro course is design, and sort of has been left over from project to project, and I do a lot of demonstrations and things get left behind, and there are additional features and things. But even with that, reason that it actually they listen to here. I'll show you for example. In here, in my designing this ability to have some kind of tower or some kind of warning system or something like that, and which already so everybody, their sensing gets turned off. They'll continue to just walk in whatever direction. They become sort of harmless. So I can kind of touch those rocks and say over here, oh, this is going to be just because I have a little character over here. Let's see. The rock, which is a rune stone, harmless because he's stunned. Easily dispatch him. And that is really handled by a very few lines of code, right? If that happens, this local action occurs, right? This local, all it does is it says, okay, set freeze to true, color it red, and sets the color back to normal. And freeze just bails out of fix update, right? So that event behavior, that ringing the bell, the gong, and so on, right? That's the beauty of the engine. That's why it's game programming. You want to build on top of things, right? You want to be designing the game, not if you want to be an engine designer and work on engine internals, definitely do that as well. But that's a different that's a different, that's game engine programming, not game programming we're talking about. All right, so particle systems. Before I let you go, I mentioned particle systems, and let's talk about particle systems. Particle systems are really, really interesting in that they are kind of, it's basically a very lightweight way to create lots and lots of objects that have some common behavior and certain algorithms that govern their behavior. They're really great. We see them, they often get used in a lot of effects, things like explosions or fire or smoke or volumetric haze and things like that. Particles, particulates in the air, right? But they can really be used for a lot of things. They can be enemies. You can have objects. You can have, flames. You can have bullets. You can have all sorts of things that are generated as particles. Now, particle system and particle effects are a lot to cover. So let me just introduce you to them away. Now, you'll notice my character here. One of the things that I think just adds a certain weight, some kind of extra something, is, I'll show you here. You'll see the character as he walks around, he actually kicks up a little bit of dust. He's got a little trail that sort of follows him. Oh, if he's not bouncing. Whoops, calm down. And these are not particle systems. Those are explosions. You can see them better on this background. But you see he kind of kicks up just a little bit of dust here. And that dust is actually a particle system. So as long as he's moving, he's generating these little particles. And the particles are governed by the direction that he's walking in. Hello, I'm a squirrel. Yes, I know, Mr. Squirrel. There you go. So that is a very different. Now, if you're doing the shoot 'em up game that's based on asteroids or something, you want to as exhaust for your spaceship, that's cool too. And explosions, that's absolutely fine too. That's to use particle systems for explosions and so on. But if you want to do something subtle with them, that's cool too. So on our hero here, for example, I'm going to go to the hero. Let's see, go to the inspector now. Find where game object on the spinning ion stone and the rotator. Where is our hero? Okay, there's our hero. And the hero has a particle system known as an effect. All right, so we want to add a component. If we decide, okay, I want to add a let's see, an effect, a particle system. If you want to add a particle system with force field, that's cool too. But let's start with just a simple particle system. All right. So then, by default, it has the duration of the particle system. Does it loop or not? So when it instantiates itself, it stays for 5 seconds and then stops emitting particles, or does it continually loop? It's already been emitting for a while, right? Speed, the lifetime of the particles, right? So it's creating these little effects, these little spawned items right away. Now let's see what happened. Where is it now? We have our particle system there. Where'd you go? No. Looping pre-warmed particle system. Oh, well, there's Z. We're going to put 0, 0. Bushes right there in the middle. I like I put bushes right in the middle of the opening there. How nice of it. So there's our particle system down there, just sort of spawning particles up. And they're invisible. They don't collide with anything. They don't do anything. They don't move around. But if you look at the particle system, you will soon find that you can do things like shape the particle system right now as a cone. And what if I want it to be a sphere, for example? And go to the game, and the sphere, it's going to emit things all around itself. So there's a different shape that it emits at. Right? The rate over time, the rate over distance. Then you can even do things like have collisions. Okay. You can have it change speed over lifetime, velocity of the emitter, and so on, and so on, and so on. I think it's colliding with the tree here, the shrub. Now, let's see if I walk down there to it. Will these collide with me? Or is that just random noise? I'm not sure. They are amazingly, amazingly powerful and require some thought and careful use. So in the case of the hero, for example, what I do in the hero is I have a sort of a dusty, earthy color to a relatively low speed. The emission is everything is kind of relatively low. The shape of it it's not out of hand by any means, right? It's a very subtle effect. And inside of my hero script, I'm actually manipulating certain things about the particle system movement. So let's see. I thought it was. Particle prefab. Increasing according to the joystick magnitude. So if I am moving, I emit particles. If I'm not moving, this goes to 0 and I don't emit any particles. The shape of the particle system is affected by also the rotation of the particle system in order to emit particles in the appropriate direction. Okay. So if you're using particles, start with the basic one. Use them for an effect. Use them as if they were in an animation. They're lots of fun. If you want to get more sophisticated, I encourage you to do that as well, but don't get too caught up in them. They're a really fun and powerful thing to try. All right, so that's more than enough for today. I encourage you to go back, watch some of. I went back and actually reverse engineered my own things to match today, so hopefully they do match. Some other things about aiming with the mouse, how my mouse reticle works, so that if you are trying to figure out how to aim things and rotate around according to the mouse's position, that's in there. Feel free to, any video that I've put up there, go ahead and reference. You also you don't have to do this. You don't have to have the RPG. It doesn't have to be top down, shoot 'em up, dungeon style. The Asteroids game is great as well. Asteroids Approach, totally fine. There's a set of 4 videos that start to finish on that. So if you are not sure exactly what to do, and the RPG is a little bit intimidating because it's more open-ended, feel free to follow along on the Asteroids, Schmupperoids track as well. That's an option. You can do that. All right. Any other questions? There's not too many people here, so I'm assuming that most people are going to be watching this offline, and I will wish everybody good luck in doing that. Have a great weekend. Do spend a little bit of time, expect as part of your submission, next Friday is when the project is due. As part of that submission, trust me, it will be better for you as well in terms of getting it done. Have that page or 2 of your design so that you know when you're done. So you don't get too much into mission creep or feature creep, like I always do. All right. Good luck. Have a great weekend. Be well. Stay safe.